Okay, this is the P1 paper from October 2020, question number 3. As you can see by looking at it, this is a radians question. We're going to be doing some work on arc length, area of sector, and there's going to be area of a triangle in there as well. That's often associated with these questions. The other thing that's associated with these questions is that they are often quite imaginative in what they ask us for an area to be. This time it's a design of a badge. All the information that they're giving me there is already on the diagram, apart from the fact that they tell me the area of the sector AOB is 7.2. This area here is going to be 7.2, and what they're asking me to do is to work out that alpha is equal to 1.6. Okay, let's go ahead and do that first part. So part A, they're saying the area of a sector, which I know is half r squared theta. They're telling me that's equal to 7.2. So if I put in the information here, half, that's 3 squared, and theta they've called alpha in this case is 7.2. So alpha works out to be 7.2 divided by, well, it's 9 over 2, so that's 4.5. Divided by 4.5, so alpha is going to work out to be 1.6 radians, just as they asked me in the question to show. Let's have a look at the second parts. It then says, hence find the area of the badge, giving your answer to 2 significant figures, and the perimeter of the badge, giving your answer to 1 decimal place. So I'll go back and check that at the end and make sure I've done that. And say, so far we just know that this is equal to 1.6 radians. So if they want the area of the badge, what I'm going to want is this area, and this area. Well, the triangles are the same as each other. So if I work out the area of AOC, if I work out the area of that one, I can just double it, and we already have the area of the sector there. That was 7.2 from my question. So I know my game plan now. I need to work out the area of this triangle in here. The area of a triangle is going to be a half BC sine A. So I need to know what that angle there is going to be. And that angle is just going to be 2 pi minus the alpha there. That will give me both of those parts. And then if I divide it by 2, it will just give me the answer for that angle there, which I'm only calling A in terms of the formula that I use. So let's go ahead and do that for part B. So if I'm doing part B, first thing I should really say is working out that angle. So COA, that angle is simply equal to 2 pi minus the 1.6 all divided by 2, and that works out to be 2.34 radians. And then the area of the triangle is going to be equal to a half BC sine A is going to be equal to a half, and what have we got there? I think we've got 5, 3, and the angle that I've just worked out. So half 5, 3, sine 2.34. Make sure your calculator is in radians. We don't want to make a mistake with that. If you plug all that in, that all works out to be 5.38 centimeters squared. So the area of the badge is equal to 2 lots of that plus the original area that they were given in the question, 7.2. So all of that comes to be 17.96, but then we were asked to do that to 2 significant figures. So just be careful with that then. That's going to be 18 centimeters squared as our final answer. B part 2 says work out the perimeter of the badge. So the perimeter of the badge is going to be this length, and this length. BC and AC are going to be the same as each other, congruent triangles. So if I can work out that length, in order to work out that length, I'm just going to use the cosine rule with this question now. I've got 1, 2, 3 in here, 2 sides and the angle in between them. So to work out that opposite side there is going to be using the cosine rule. So I'll do that and I'll work out AC. I also need to work out the length of this arc here, but that's easy because, again, if I've got r and theta there, that's just going to be L equals r theta. Okay, that's explaining it to you. Let's now go ahead and explain that to the examiner. This was B part 1. Next part is going to be B part 2. So I'm going to actually do let me move that down. I'm actually going to do the arc first of all. So just tell them what you're doing for arc AB, just in case I've made any mistakes, and I'm going to try and get at least a few marks of method. The arc length L equals r theta. Dead straightforward. We've got everything here. We've got 3 times 1.6. So the arc is 4.8 centimeters. And then for AC, I always like to quote the formula: a squared equals b squared plus c squared minus 2bc cos A. Why do I like to quote the formula? Because every time I write it down like that, it's going a little bit further into my memory bank. Really good to know all your formulae rather than to be looking out for them on formula sheets, whether you do an IGCSE, AS, A-level, doesn't really matter. So I always write the formula down. The other thing is, it means I'm less likely to make a mistake copying things in. It's AC squared that I want. Well, the sides are 5 and 3, 2 lots of 5 times 3 cos, and the angle was 2.34, wasn't it, from before? Just be careful to make sure you're getting the right angles each time. Chuck all that into the calculator and work it all out. I'm not going to do that for you. Not AC squared, sorry. AC then works out to be equal to 7.4, which means that the perimeter that I actually want is AC plus BC plus arc length. Arc was AB, wasn't it? So that works out to be 7.4 plus 7.4 again, plus, what was the arc length? 4.8. Every time I'm doing those those calculations, I'm writing down 7.4. I use the whole number on the calculator till the very end and then do it to the number of decimal places. But here, that works out to be 19.6 centimeters, which is the answer for the final part. But train yourself to go back and just check. Did you answer all the questions? Did they all make sense? Especially on these ones, to make sure you got your decimal places and your significant figures. Right, hopefully that makes sense.